Um, Before we really get into things today, I do need to explicitly state right at the very beginning that this broadcast is an AI-generated analysis.
Right, exactly. But, we are still unpacking all the real concepts and methodologies today.
Yeah, absolutely. So imagine this. You spend like 3 weeks writing what you think is the most elegant, computationally perfect algorithm of your entire career.
Oh, yeah. Every engineer's dream. Flawless code.
Right, the code is totally flawless. But then a month later, you find out it actually lost the company money.
Ouch.
Yeah, because it solved the problem that the user didn't actually have.
Which is just the worst realization.
It really is. And that perfectly captures the profound difference between being just an efficient coder and being a truly effective software engineer.
It's a massive shift in mindset.
It is. So welcome to this comprehensive analysis. Today, we're examining the foundational concepts from the book, The Effective Software Engineer by Adi Osmani, published by O'Reilly.
It's such a crucial read.
Definitely. And the objective of this detailed technical review is to really explore how individual contributors, or ICs, can leverage things like AI, prioritize high-value work, and make that vital transition from mere efficiency to true effectiveness.
Yeah, and to really frame this entire discussion, I think we have to look back at Peter Drucker.
Oh, the management consultant, right?
Exactly. He had this great concept where he noted that efficiency is simply doing things right. So in our field, that means like writing an elegant algorithm or closing a ticket super fast.
Do the task perfectly,
But effectiveness, conversely, is doing the right things.
which means building a feature the user actually desperately needs.
Exactly. So the big question for you as a listener is, how does a highly skilled coder actually become a company's most valuable asset?
Right. And that transformation, it requires a pretty fundamental shift in how an engineer views their daily responsibilities, doesn't it?
Oh, absolutely. I mean, efficiency is just considered the absolute baseline in modern engineering today.
Like table stakes.
Exactly. Writing clean, performant code is just expected. But an individual contributor can produce flawless syntax at this incredible velocity and still be entirely ineffective.
If they're completely disconnected from the business objective.
You hit the nail on the head. The source text really emphasizes that true effectiveness focuses strictly on maximizing positive outcomes for the business and the end user.
So it's about strategic alignment with the product vision.
Right, rather than simply maximizing the sheer volume of code you push to a repository.
Yeah, before an engineer can leverage advanced tools or influence the broader org, they have to establish this baseline of focusing on business value.
Definitely.
So let's look at what engineers are actually building day to day to understand this shift. The text establishes a really clear boundary between outputs and outcomes.
This is such a critical distinction.
It really is. Outputs are the tangible deliverables, right? Like the raw number of PRs merged or the lines of code written.
Which are easy to measure, but often misleading.
Exactly. Whereas outcomes represent actual changes in user behavior or, tangible improvements in system capabilities.
Yeah, the book gives a really clear scenario to illustrate this.
Right, the engineer A versus engineer B example.
Yes. So consider engineer A. They spend, say, 3 weeks building this highly complex recommendation algorithm.
Super technically sophisticated.
Right. But analytics later reveal it's buried so deep in the UI that literally nobody uses it.
Wow. So that's a massive output, but a completely failed outcome.
Exactly. Now consider engineer B. They notice the checkout process times out during peak traffic hours.
A real user pain point.
Right. So they spend merely 2 days implementing a very simple queue system. That small output reduces checkout timeouts by like 85%.
Which directly and immediately increases the company's revenue.
Exactly. That is highly effective engineering.
It's a huge difference. But, building on this outcome-oriented mindset, the foundation of effectiveness still requires rigorous adherence to clean code principles, right?
Oh, for sure. You still need concepts like KISS Keep It Simple, Silly and Yagi and I. You aren't going to need it.
And the solid principles, obviously.
Right. Furthermore, the text advocates for a really strict tests-first mindset. And it demands treating debugging as, like, a rigorous scientific discipline.
Which means, what, not just randomly scrolling through system logs?
Yeah, no random archaeology hoping to spot an error. The effective engineer forms a specific, testable hypothesis about why the system is failing before they ever open the log files.
But wait, let me push back a bit here, because the difficulty lies in actually applying those principles when, say, a PM is demanding complex features on a super tight deadline.
Well, yeah, keeping it simple requires pushing back. It means asking if the user truly needs 5 different filtering options or if one robust search bar will achieve the outcome.
Right. And that's where things like object-oriented design and solid principles are incredibly useful.
Exactly, like the single responsibility principle, which dictates that the module should have only one reason to change.
So when business requirements inevitably shift, your code base can adapt without catastrophic regressions.
Right, it prevents the system from becoming a tangled web of dependencies.
But I want to challenge the industry standard regarding how we actually measure this success. Because measuring an engineer primarily by lines of code. I mean, it's like measuring a commercial airplane's quality by its total weight.
That's a great analogy. It fundamentally misunderstands the purpose of the machine.
Right. So if a company's culture primarily rewards raw output and highly visible chaotic activity, how can an IC practically measure their own effectiveness without relying on those flawed dashboard metrics?
That's the real challenge. To navigate an environment obsessed with raw output, an engineer really has to take ownership of their own narrative
Yeah, how do they do that?
by maintaining a personal business impact tracker.
Oh, interesting.
Yeah, it's this deliberate practice of translating technical tasks into business language. So instead of simply recording, hey, I deployed a new caching layer,
Yeah.
the engineer documents the specific outcome.
So they record that the caching mechanism reduced page load times from, say, 3 seconds to 1 second.
Exactly. And then they connect that technical metric to the actual business result. They note that the faster load time increased the mobile conversion rate by 8%.
Wow. By linking daily tasks to actual user sentiment, they build a factual, undeniable narrative of their value.
Right, and this tracking not only provides clarity and motivation for the engineer, but it gives them empirical data to advocate for their career progression during performance reviews.
So you're tracking your impact, you're focusing on user outcomes. Once an engineer consistently delivers that outcome-focused code, what's next?
Well, the next major challenge is scaling that impact across the entire system and the broader team.
Which brings us to the crucial concept of T-shaped skills.
Yes, T-shaped skills. The text defines this as cultivating deep authoritative expertise in one specific domain like database optimization or backend architecture.
That's the vertical bar of the T.
Right. But simultaneously, the engineer has to maintain a broad, functional understanding of the entire technological stack.
A horizontal bar.
Exactly. Cultivating this breadth prevents that severe tunnel vision that often afflicts deep specialists.
Because it helps them design for long-term scalability.
Yeah,
They understand how a change in their microservice ripples across the whole ecosystem.
precisely. Furthermore, scaling your impact requires the ability to influence without formal authority.
Right, you're an IC, not a manager.
Exactly. Effective engineers proactively collaborate with PMs and UX designers. They insert themselves into the product ideation phase early.
To guide technical feasibility rather than just passively waiting for rigid specs to be handed down.
Yeah, you have to be in the room where it happens.
But let me raise a practical dilemma here.
Yeah.
How does an engineer justify spending valuable time building breath-like learning a totally new front-end framework when their immediate sprint deliverables strictly demand deep specialization in the back end?
It's a fair question. But building breadth doesn't mean abandoning your deep specialization or, missing your immediate deliverables.
So how do you balance it?
You organically build that breadth by deliberately participating in cross-functional code reviews and by contributing to architecture decision records, or ADRs, outside of your primary domain.
Oh, I see. So by reviewing code from adjacent teams, you learn the vocabulary, the syntax patterns.
And the operational constraints of other systems, yeah.
Right.
You absorb the knowledge without the heavy burden of full implementation.
That makes a lot of sense.
And participating in architectural discussions gives you vital visibility into the broader product strategy.
So when the back-end engineer designs a new API, they actually understand how the front end consumes the data.
Exactly. So the time invested in reviewing outside code is really a direct preventive measure against future integration failures.
It's a highly justifiable investment in the overall velocity of the engineering department.
Absolutely.
Okay, so you've built your T-shaped skills, you're collaborating beautifully across departments, but as an IC's influence grows, they inevitably encounter systemic organizational dysfunctions, right?
Oh, definitely. Recognizing and mitigating these anti-patterns is absolutely essential to maintaining long-term effectiveness.
Let's examine the individual anti-patterns first. The source material heavily highlights the hero complex.
Yes, the hero complex. It's like hard coding a temporary patch into the core architecture of a system.
Right. It fixes the immediate critical crash, and the engineer gets praised for working through the weekend.
But the entire system is now permanently dependent on that single undocumented line of code not breaking again.
It creates a super toxic culture of extreme dependency.
It really does. Then there are knowledge silos, where an individual hoards critical system info for perceived job security.
And we also see over-engineering.
Right, which directly violates the YEGN principle by building these massive, complex solutions for speculative problems the business doesn't actually have.
Now, on the team level, a critical dysfunction is flaky product ownership.
Oh, the just one more thing syndrome?
Exactly.
Mm.
It introduces late-stage scope creep that just severely damages code quality, destroys sprint planning, and totally exhausts the engineering team.
And this dysfunction directly impacts the bus factor.
Right, the critical risk metric.
Yeah.
For those listening, the bus factor determines how many people would need to suddenly leave a project before development completely stalls.
Yeah, if only one person understands the deployment pipeline, your bus factor is 1, which is an unacceptable risk.
So the text prescribes structural remedies like mandatory pair programming, strict definitions of done, and rigorous agile ceremonies like honest retrospectives. Right?
Yes, exactly, to distribute that knowledge.
But I have to push back on the emotional reality of those remedies because it feels incredibly unnatural for a senior engineer to step back and allow a junior colleague to struggle for 4 hours with a bug when the senior knows they could resolve it in 5 minutes.
It does feel unnatural at first.
How does one systematically override that deeply ingrained instinct to just intervene and fix it?
Well, overriding that instinct requires a fundamental redefinition of senior effectiveness.
In what way?
The transition from a mid-level contributor to a senior engineer requires recognizing that your ultimate output is no longer just the code you personally write.
Your output is the total combined execution of the entire team.
Exactly. Stepping in to fix the junior engineer's bug in 5 minutes is highly efficient in the short term, but it is disastrously ineffective in the long term.
Because it just reinforces the knowledge silo and keeps the team's bus factor at 1.
Right. Delegation and deliberate mentorship have to be viewed as strict, non-negotiable technical requirements of the job, not just optional soft skills.
So the psychological discomfort of watching a junior struggle, that's just the necessary cost of transferring complex system knowledge.
It is. By guiding them through the scientific debugging process, asking them to formulate hypotheses rather than just handing them the solution, the senior engineer effectively duplicates their own capability within the team.
Which, over a 6-month timeline, drastically reduces the operational burden on the senior engineer.
Exactly, freeing their schedule to focus on high-leverage, strategic architectural initiatives.
Right. But mentoring juniors, fighting scope creep, dismantling toxic dynamics, that requires an immense expenditure of personal energy.
That's exhausting.
So to maintain this elite level of effectiveness over a career spanning 2 or 3 decades, engineers really must learn to ruthlessly protect their mental bandwidth.
Absolutely. And they have to adapt to modern work environments. The text introduces the 80-20 rule, or Pareto principle, specifically applied to software engineering.
Right. So mechanically applying that, an engineer must identify the 20% of the code base, or the feature set, that drives 80% of the actual user value.
Right. Effectiveness means directing your optimization efforts strictly toward those critical pathways, rather than, say, polishing legacy modules no one uses.
Furthermore, strategic thinking requires translating technical issues into standard business language.
This is huge. Instead of telling executive leadership, oh, the system has accumulated too much technical debt, the effective engineer explains the precise revenue risk of prolonged downtime.
Or details the exact financial maintenance costs incurred by delaying a refactoring project.
Exactly. Speak their language. The book also strongly emphasizes the critical importance of avoiding burnout.
Acknowledging that software engineering is a marathon, not a sprint.
Right. Working in sustainable, predictable cycles. Taking completely guilt-free vacations where you actually disconnect from all communication platforms.
And maintaining strict vigilance for the early signs of workplace cynicism. But in the context of remote work, the mandate is defaulting to extreme transparency, mastering async communication, and documenting everything.
To bridge global time zones, yeah.
But I have to question the modern remote work culture of constant connectivity. In an environment that explicitly rewards immediate replies on Slack or Teams, how does an IC draw firm boundaries without appearing, uncollaborative to a distributed team?
The solution lies in aggressive, proactive communication regarding your status, coupled with the strategic use of modern async tools.
Okay, so how does that look in practice?
To protect deep work focus blocks, an engineer must broadcast their availability clearly and predictably.
Like explicitly communicating, I will be offline for the next 3 hours to architect a database migration, and I'll return at this exact time.
Exactly. Furthermore, the tech suggests leveraging artificial intelligence meeting summaries to defend your schedule.
Oh, that's smart. So if a sync meeting spans multiple time zones and threatens to interrupt a focus block,
The engineer can just decline the meeting, rely entirely on the AI-generated transcript and action items, and respond asynchronously later in the day.
wow. By documenting architectural decisions comprehensively and maintaining visible status updates, the engineer demonstrates supreme collaboration.
Yes, and it totally eliminates the perceived need for instantaneous replies. This discipline preserves the vital cognitive energy you need for complex problem solving.
Which perfectly leads us to the most powerful leverage an IC has today, the pragmatic integration of artificial intelligence into their daily workflow.
Oh, absolutely. But the text establishes a firm, unyielding rule here.
That AI is a tool, not a replacement.
Exactly. It's a powerful tool designed to automate routine tasks and amplify human judgment. It excels at generating boilerplate code and basic syntax.
But the human must supply the vital business context and the overarching architectural intent.
Right. The book introduces this highly effective workflow called the tests first, then code pattern.
Okay, walk us through that.
It involves the engineer defining strict acceptance criteria, using the AI to write comprehensive unit tests based on those criteria.
And only then generating the actual implementation code to pass those specific tests.
Precisely. Crucially, engineers must practice a technique called context sandwiching.
Right. This means you don't just ask the AI to write a function. You provide the overarching system architecture first, the specific coding task in the middle, and the strict security constraints at the end.
Yes. This prevents a very dangerous practice known as vibe coding.
Vibe coding. That's defined as blindly accepting AI-generated code without thoroughly verifying its underlying security implications or performance bottlenecks, right?
Exactly. To mitigate this risk, engineers have to utilize OWASP, the Open Worldwide Application Security Project, top 10 prompts, to ensure the AI generates secure, defensive structural scaffolds.
Additionally, AI serves as an exceptional tool for summarizing massive product requirements documents into actionable, agile backlog items.
And drafting the initial structure of ADRs.
It's exactly like supervising an incredibly fast, highly productive, but exceptionally literal junior developer.
That's the perfect way to look at it.
But I do have a critical question regarding long-term skill retention here. If the human defines the parameters, lets the AI generate the tests, and lets the AI generate the code,
Right.
how does the engineer prevent their own deep system comprehension and fundamental coding proficiency from eroding over time when the machine is doing all the typing?
That's a common fear. But system comprehension doesn't erode because the human engineer permanently retains the role of chief architect and meticulous reviewer.
Oh, I see.
By systematically offloading the generation of basic syntax and repetitive boilerplate to the AI, the engineer doesn't stop thinking. They just elevate their cognitive focus to a much higher, more critical plane.
So the mental energy previously spent remembering tedious syntax for a database connection is reallocated.
Exactly. It's reallocated to scrutinizing the security perimeter, evaluating the long-term scalability of the system, and ensuring the final implementation flawlessly serves the intended business value.
Because the engineer has to comprehensively understand the entire architecture just to write the precise prompts required for context sandwiching.
Exactly. Furthermore, they must possess deep technical expertise to rigorously validate the AI's output against obscure edge cases the model simply can't anticipate.
So the AI handles the mechanical typing while the human executes the strategic high-level engineering.
You've got it.
And that shift from mechanical typing to architectural strategy really reveals the ultimate trajectory of our profession.
It absolutely does.
As we conclude this comprehensive analysis of the effective software engineer by Adi Osmani, we really have to look toward the future of the IC role.
Right, we've explored the critical shift from raw efficiency to business-aligned effectiveness.
We analyze the necessity of balancing technical depth with strategic breadth.
We discussed dismantling toxic team anti-patterns, protecting mental health through strict boundaries.
and the highly practical integration of AI into the daily development workflow.
So I will leave you with a forward-looking concept to deeply consider. As artificial intelligence continues to rapidly commoditize the raw mechanical act of writing syntax, the traditional title of software engineer may soon become entirely obsolete.
Wow.
We are witnessing an evolution toward titles such as value architect or systems thinker. In a future where machines can generate flawless, performant code instantaneously, your strategic judgment, your deep understanding of human needs.
And your unique ability to align technology with actual business outcomes.
Yes, those will become your only irreplaceable assets. So, are you fully prepared for a professional landscape where your mechanical, technical execution is entirely secondary to your strategic, critical thinking?
That is a phenomenal question to end on. We strongly recommend that you read the actual book, The Effective Software Engineer by Adi Osmani, to fully grasp and implement these complex methodologies.
It really is a must read.
To all the friends of the show listening, we encourage you to subscribe to receive our future comprehensive analyses. We wish you a great day.